successful today, you're going to have watched my video on the remainder theorem, which was assigned over the weekend. As well, you're going to be able to, or you're going to need to be able to use polynomial division to divide up some polynomials. Okay? So, since we're dividing polynomials, what we're really doing is trying to factor a polynomial. So polynomial division is important to us when we're looking at how to factor a polynomial. So let's just take a look at a question. Let's use the remainder theorem to determine the remainder when this polynomial is divided by the binomial x minus 1. And then we'll later on look at the answer to part B as well, determining the quotient. So if I'm taking a polynomial and I'm dividing it by a binomial, we did this in class today as an example, or something similar to this. We set up our polynomial and arrange it in decreasing power. It doesn't really apply in this question, but we want to make sure we have any place value holders if we need them. And then we start dividing. And multiplying by the binomial. We'll bring down the next term. And subtract again. End up with 2x. Bring down the negative 2x. And look what's going to happen. I end up with a subtraction that ends up canceling out everything that's left in my long division. We can think about what this means, and we can see what it means the best when we answer part B. When we determine the quotient of x cubed plus 2x squared minus x minus 2 over x minus 1, we see that this is equal to x squared plus 3x plus 2 plus a remainder of 0 over x minus 1. If I cross multiply by x minus 1, if I bring that term up, I see that my original polynomial is equal to x minus 1 times x squared plus 3x plus 2, and this term, the remainder term, gets cancelled out. Okay, it's just 0. So what I've really done by dividing this polynomial and ending up with a remainder of 0 is I've factored it. I've factored this cubic polynomial into a binomial of x minus 1 and a factor of x squared plus 3x plus 2. And I can go even further. I can keep factoring. We know how to factor this quadratic. I need to find or think of two numbers that multiply to 3 and add to 2. And I think those numbers are x plus 1 and x plus 2. So now I've done something that we haven't been able to do before. We've taken a cubic function and we've factored it fully. And if we think about what this means in the context of the last unit, we've gone from a polynomial of degree 3 that we wouldn't have been able to graph without some graphing technology or a table of values, and by factoring it, we could now graph that. We know what the x-intercepts are. We know the value of the leading coefficient is positive. We could graph that pretty easily. So this leads to today's theorem, the factor theorem. We know that a binomial is a factor of a polynomial if we can sub in that value b and we get a remainder of 0. Okay, so this factor theorem is related to the remainder theorem. Remainder theorem tells us what the remainder would be if we were to divide it, and factor theorem is telling us that if we sub in a value into a polynomial and we get an answer of 0, then that number must be a factor of the polynomial. So one more example in this online video lesson. We want to know, without dividing, which of the following are factors of the polynomial p of x minus 3 or x plus 2. So to solve part A, I would sub into my polynomial the value 3. So I'm subbing that in for every x value. I get 27 minus 9 minus 42 plus 24. And I can plug that into my calculator and I get an answer of 0. So based on the factor theorem, if I sub in this value into my polynomial and I get a value of 0 out, then that has to be a factor. Take a look at question B. I'm going to do the same thing. I'm going to evaluate the polynomial at -2. Solving that, plugging that into my calculator, I get an answer of 40, which means if I used polynomial division and I divided by x plus 2, I would end up with a remainder of positive 40. So that's all that I want to talk about today. I would suggest taking a look on the online textbook at page 102. Try question 2 in preparation for tomorrow. Tomorrow in class we're going to go a little bit further in depth into the factor theorem. So please make sure you're ready. See you tomorrow.